Okay, I hope you're at the point where you're looking at the Sage code and say, well, do I need to type that in? Maybe, maybe not. Right. What I'm claiming over here is you probably learned enough Sage now that you could look over the problem set and experiment. All right. Now, when I say Sage, in addition to Sage, also some other tools that you might be using, whatever is convenient for you. All right. So what I want to do is just scroll back on the problem. I'm not going to type that Sage code in, but I'm going to look back at a problem that we did in class. And I'm looking back, not the homework. And some of these problems are rather difficult. I realize that. I will look at something that, maybe I could do. All right. So I'm going to look at problem number 3 that we've done by hand. Pretty easy to do. But again, I want to see if I understand if I can do this using Sage. All right. And again, the point is not to use Sage. The point is to learn how to use Sage. Like I would not want to use Sage for this particular problem. So what I'm going to do, just from the get-go is I'm going to open up Sage. And I think I have some memory of what I've done before. I'm going to reset. Again, if you've not been interacting, there's no memory. I mean, you got to engage yourself and study, right? I'm going to say X is a variable. And actually, you should be better than your teachers. And the reason that you're more engaged in the subject. Teachers are just simply here while they're teaching. They're not going home and doing homework. You are. All right. I'm going to type in f of x. It's a function. And that function is going to be assigned x divided by 1 plus x squared. And what I want to do is I want to plot it. And so what do I want to plot it? I want to see if I get the same picture this guy got. All right. So let's plot. I'm going to plot f of x. And let's see. No, I was going to plot. I'm not going to put anything down. I'm going to see how it does. And I don't like what it did, right? Because it's not the same thing that I have in the notes here. So I'm going to rework it. And what I'm going to do, well, I'm going to look at my notes and say, oh, you're cheating now. You're looking at your notes. No, you're studying. And I'm going to say x min looks about, I don't know, -6, right? I'm just ballparking it. And x max, whoops, looks about 6. That's better. All right, I'm seeing it. All right, I'm definitely seeing it. And what am I seeing? I'm seeing a picture. It looks sort of like the one I've given you over here. All right, sort of. All right. So I want to go back. I'm going to close this out. I'm pretty satisfied with the picture we received. It's a pretty good picture. I want to see if I get the second derivative. Now, someone says, I can't remember how to get the first derivative. You're not engaged enough. But let's go through this. All right. I'm going to go to Sage. Let me clear. And what I want to do is I want to take the derivative. That's DIFF. Let's see, f of x with respect to x. And that's the first derivative, right? Let's see how it does there. Pretty good job. I'm going to do full simplify. Hope I type things in right? It gives me something a little bit better than what was there before. Combine those two terms into one. But I didn't want the first derivative. I want the second derivative. So let me see if I can remember. All right. So I'm going to think I can remember. I'm going to say 2. Maybe this isn't right. Maybe I have to look up derivative. All right. I'm going to do full simplify now. And let's see if we got it. You notice, I noticed that mine looks sort of like theirs, right? I'm just going to go through it with you. They have 2x cubed. Yep, I'm seeing that. Yeah, I'm going to do bool. I don't want to look at that. I'm going to do bool. I've done bool before, right? What's bool? It's a Boolean algebra. And I want to see if this thing here is the same thing as what I've written over there. What I've written down, 2 times x squared minus 3 divided by 1 plus x squared cubed. Now I'm expecting to see a true. Yep, it's true. All right. Now someone says, well, what did you just do there? It said find a flex point. How do I do that? Well, I could look at my picture and ballpark it, but I want to use Sage to do it. All right. So what am I going to do? I'm going to take this thing here, right? And certainly, I want to point out, I prefer to look at this derivative over here. It's not undefined anywhere, but it is zero somewhere. And I'm looking at it and I know where it's zero. It's zero at zero, right? It's zero at plus or minus root of 3. But I'm going to see if that's true. So I'm going to say solve this equation, zero. And I claim there's 3 answers to it. Again, remembering what I've done in the past. And I remember what I said, looking at it, it was 0 and plus or minus root 3. So what am I claiming about this picture over here? Well, let's look at it. I'm going to say it's 0. There appears to be a point of inflection. It appears to be concave up here and then concave down over here. But they also claim at the square root of 3. And this is where a lot of students are really struggling with numbers. So I wanted to put down the square root of 3 for you. About 1.7, right? Let's look over here. I'm going to blow this thing up. All right. And 1.7 is I go over here. Now, if you trace up there, what do you see? Well, I'm seeing a point of inflection. It's concave down, concave up over here. And they also said one occurred at minus root 3. And minus root 3 is over here approximately. Concave down, concave up. Certainly fitting our description. Again, looking at the key, we go on to say the points of inflection occur at plus or minus root 3, and it's 0. And we give you a graph of it to help you out with that. Okay, that's about it. There's not much else to say about that, other than the fact that you may want to go through the assignment again, look at some of the stuff over here. Again, the graphs that we're producing over here, I produce them with Grapher. You may decide to use different software. Here's the deal, though. Get familiar with tools. Tools are going to allow you to do problems that are much richer than the ones we're presenting to you, which are basically done by hand. However, I want to point out the weak thing for a lot of students, even at this level, is these problems, although we say they're very simple problems, a lot of students don't possess the necessary algebra skills or trig skills to solve these problems. And why is that? Well, maybe their expectations in those courses wasn't met. They really didn't live up to the expectation the teacher might have set for them. And that is to master the material. That's our expectation. Again, if you're thinking about moving forward in stage, the expectation the teachers have is that you're going to master material well enough where you could actually move forward. All right. To move forward, though, doesn't mean to sort of like lag around. It actually means an active participation on your part to move forward. It takes time and it takes effort. Thank you.